Thank you. Thanks very much. It's nice to be back. I mean, I'm more confident today because that day was my first presentation, so I'm more experienced in a way. Thanks to your very warm welcome. I spoke to Lynn just before I came in that today we will cover the other side of gems. The first time we talked about diamond. Diamond is more defined because it's a single entity, separates itself from the rest of the gemstones. Gemologists who are academics have separated the subject, so we could teach it within an hour or two. When it comes to gemstones, I had the choice today to brief you for an hour, and you will go and you will remember just basic titles, but I consider that if we do a series of 3 or 4 programs, you will be able to learn something that will stay with you. Not too academic, as always, something simple, but today I'm going to cover an introduction about gemstones, and then in the other programs we will do, we can be more specific about certain gems, certain groups of gems, what separates them, and all this. So please be patient that today we won't cover the whole thing. It's just an introduction. And what is a gem? I mean, we've got to define what is a gem. A gem practically is a mineral. It's something that we classify as a mineral, and because we humans like it, it's a trait for some to take a crystal from the earth and polish it and shape it so it looks nice. That's what it is. That is a gem. Because we like it, not because it has any other qualities. It's because people, mainly ladies, seem to be attracted to this kind of adornment for centuries, starting from the Egyptians, even further beyond, you know. So it's something that we like. So how we like it, how it became part of our lives, had become more defined, and people have chosen it as a science. So practically a gem is a mineral that we love. So what is gemology? Gemology is the science. It's the science that mainly British academics started to define each and particular crystal, what it is, what physical properties it has, but mainly define it in comparison to the imitation crystals. Later on you will understand what I'm saying. So gemology is a science. Where are gems formed? Formed practically from the interior part of the planet. There are many ways that gems are formed, but just to give you a basic understanding, they come from volcanoes. Is the volcanic lava that steams up from volcanoes, and that through heat and pressure crystallizes, and that's how we get the mineral. So practically, please consider that gems come from volcanoes. They surface in various locations like rivers and all this, but mainly it's a volcanic lava. That's what it is. When it comes to identify gemstones, the eye is never enough. When it comes to diamond, the eye can do a lot, as we talked before. But when it comes to gemstones, you cannot separate a gemstone, or you cannot identify a gemstone just by looking at it. It's never enough. Especially this day and age where we see all sorts of technology being involved, and we can put 2 identical gems. One can be synthetic, the other can be real, and we cannot separate it by eye. So I'm afraid to the individual person like you will never be an expert as to identify a gem. You've got to trust, again, the person who is selling it to you. So, and you will see now what I mean, because to identify a gem, you must do certain tests, which sometimes I don't do because it's not my field completely. So let's recap. What is a mineral? A mineral has a chemical composition. practically is chemicals connected that gives you a crystal. Diamond is a single entity, is carbon, that's what it is. Sapphire is aluminium together with oxides. So any gem has a separate chemical composition. It is complicated, and science and laboratories can do this, but practically we start that each gem has a chemical composition, which to you and me doesn't mean anything, because how do we know, you know? Academics or people in laboratories can tell us that a certain gem, like an emerald, has this formula, or a sapphire has this formula. So that's what it is. It's a chemical composition. That's the first thing they can identify, but that's not enough. There is another test further down the line that we call refractive index. We all know that if we have a glass of water and we put inside the straw, we can see the straw broken. I'm sure I'm trying to explain it like, you know, this tells us that light travels differently through air to any other media, either water, liquid, or crystal. This angle, let's say this is the angle that we see in the glass, the angle you can measure. Each individual gemstone has its own angle, what we call refractive index. And it is something that you can read with a specific instrument, which again, for you, is not something you will have at home, but first is the chemical composition, then is the refractive index. Each gem has a separate refractive index. It's one of the wonders of nature. How come? We don't know. But each gem, a sapphire has a different one, an emerald has a different one, and it's a constant. You can get the same refractive index if the sapphire is from Southeast Asia or Russia or anywhere. It is the same refractive index. This is something that is a constant. So it's a practical test to separate gems. That's test number 2. We all know that when we have a glass of water and we put in it, let's say, a stone, water elevates. Or if we get in the bathroom, the water elevates. In other words, the water accepts our weight, so it rises up. Each gemstone has a separate specific gravity index. It will, if we are to immerse any gemstone in a liquid, each gem from nature is displacing a certain amount of water, let's say, or liquid, and it's specific to each gem. Again, it's something that is a constant. We don't know why, but we know it's a fact. So we have the chemical composition, we get the refractive index, and we get the specific gravity, which are the 3 main tests that you can do that more or less a laboratory can tell you this is a sapphire, this is a tourmaline, this is an emerald, and whatever. These are the 3 main tests. Now, what is more common as a test is hardness, and we all know that diamond is the hardest material. I'm sure this is a common knowledge for all of us. Hardness is not if a diamond or a gem is hard enough. It's all about scratching. Diamond is the hardest material because no any other crystal can scratch it. The other way occurs. A diamond, if you scratch it against the sapphire, there is a line. If you scratch a sapphire against the topaz, there is a line. But it's about scratching. As a common knowledge example is, years ago,